Welcome to this episode of Let's Be Civil. On this episode of Let's Be Civil, I'm speaking with Tom Adams. Tom Adams has been Executive Director for the American Coal Ash Association since 2009. Prior to joining the association, he was employed by the American Concrete Institute, following over 30 years in the ready-mix concrete industry. Okay, everybody, thanks for joining us on the Let's Be Civil podcast. And today we've got Tom Adams from the American Coal Ash Association, and I'm going to try to share the screen here and pop up. There's their webpage and the picture of Tom. So the home office is actually there with American Concrete Institute, correct?
That's correct, yes.
Correct, yep. So American Coal Ash Association. So what the heck is coal ash?
Well, I think most people are aware that when you burn coal to generate electricity, not everything burns. And the non-combustible materials that are left behind after you burn a ton of coal, which is somewhere between 5 and 10% of that ton stays behind, has to be managed in some way. And you can imagine that as you burn massive quantities of coal, as we've done for quite a while, that generates a lot of material which either has to go to disposal units, which are either landfills or ash ponds, or be placed into some kind of beneficial use, or what more popularly is called recycling, but it's not technically recycling. But beneficial use is a term that they use in regulatory documents all over the place.
Sure. So you answered one question. What was happening with this material before? And so what was happening before is it just got shoved basically in the corner and out of sight, out of mind in a way.
Yeah, over the decades, John, if you look at energy generation using coal over the last several decades, early on, utilities were able just to place the material in ash ponds on their property or into landfills, into dry storage, and thought nothing of it. It was a bit of a nuisance for them, but they had to do something about it. Over time, actually starting in the late 1940s, the concrete industry started to take an interest in using fly ash in concrete when they started building some of the massive dams out west. The Hungry Horse Dam in Montana was actually the first one to use fly ash, and that was used for the purpose of course, controlling the heat of hydration within that dam to prevent cracking, or at least try to mitigate the cracking. So that's where the idea of using fly ash in concrete really got started in the modern era, and it just started to grow gradually as people could see the benefits of using the material for things other than mitigating heat of hydration.
So when you say that, that there's this relatively small percentage of material that is left behind, it causes me to say, well, what do you mean material? So I know what you're referring to, but for us to have, a conversation for others, what is actually the material, and then where is it physically? Where is it in sort of the coal burning process that I go get it and now use it, as opposed to put it, someplace else before? So.
Yeah, fundamentally, there's 4 materials that come out of most power plants that burn coal. 2 of them are ashes, 2 of them are not ashes, but they all fall under this label of coal ash, or as the Environmental Protection Agency calls them, coal combustion residuals. Fly ash, as you inject pulverized coal into the boiler to generate steam, fly ash are the finely divided particles that actually just fly up to the top of the boiler and are collected in a bag house at the top of the boiler. Really, fineness is something on the order of a very fine Portland cement in terms of particle size. The second material is bottom ash, which is, guess what? That's found at the bottom of the boiler.
Okay.
So the fly ash flies up to the top, bottom ash falls to the bottom. It tends to be a granular material, kind of like a coarse sand type material. Chemistry is very much similar to the fly ash. After all, it came out of the same coal. It's just a heavier particle. The other two materials, one is a boiler slag, and that boiler slag comes out of a very special type of cyclone boiler, which is an old technology. It's actually a fairly clean material, but most of the plants that have been built in the last 30 or 40 years don't use these cyclone boilers. So that is a process that's retiring because of its age. And the last one of the four major materials is not an ash either. It's actually synthetic gypsum. It's called flue gas desulphurization gypsum. And as flue gases leave the power plant, before they can be released into the atmosphere, they have to have their emissions controlled. And the emission control technology that's used to meet clean air standards produces this synthetic gypsum, which interestingly enough is just a little bit more pure than the material we dig out of the ground and have been using for a long, long time. Okay. So coal ash covers really two things that are not ash.
Okay. So you said in the 40s is first use. Where does the association kind of come along in the timeline, and maybe if you might comment, like what was happening prior to the association starting that caused the association to start? So obviously there's something had to trigger that, but then how have things changed since the association has actually been in place? So it's kind of like, what is it that you do?
What is it that you do? That's a very good question. That's changed over time. As the use of fly ash started to get traction in the late 40s, folks started taking a closer look at these materials, and utilities started to occur to them that we can't just keep placing this material in landfills and ponds. We need to find other uses for it. So just the environmental management of these materials put some pressure on utilities, and also the marketplace started to realize that these products had value. And we actually had a small industry that was in communication with our counterparts in Europe in particular, and we were trading ideas about who's doing what with these materials and how to best educate potential users on how to use the materials. And eventually this industry kept growing and growing, and in 1968 the National Ash Association was founded, which was our beginning of our association. And the purpose was to educate any interested party, but particularly potential user groups, on the benefits of using these materials. And that was the initial motivation for founding the organization. Over the next decades, that was our primary activity, was conducting training, doing education, and working with potential partners, including the U.S. Environmental Protection Agency when that organization was founded, to move the beneficial use of these materials forward and stop, sending things to landfills and to ponds. And that was the focus of our organization for a long, long time, is just training and education. And today, we're at a point where we're using 58% of the material generated annually, which is it's good, but it still has a lot of room to grow.
Mm-hmm. So I want to clarify something so people understand the terminology. Explain what a pond is. What's an ash pond? The terminology that you find in the technical documents is a surface impoundment,
technical term that's applied to these ponds. How these ponds are used or were used is utilities found that to get these ash materials out of their power plants, particularly for bottom ash and fly ash in some cases, they could take massive quantities of water and sluice the material, wash it right out of the power plant into a storage pond, and it was the fastest and cheapest way to get the material out of the plant. So you can imagine that over time, some of these ponds became extremely large. And today, environmental regulations are requiring that utilities start to shut these ponds down and either cap the material in place after it's been dewatered, or remove the material completely and haul it off to a landfill that has complete liner systems and all these kinds of things. So
this isn't.
So the ponds were a cheap answer to the disposal challenge.
Sure, but these aren't ponds with fish in them that you then go dump this material in, or they are.
Oh, yeah, absolutely. Okay. If you saw some of these ponds, you'd see all kinds of wildlife around the ponds, and with no significant impact on those species.
Okay. I just wanted to make sure people understood the term pond as it relates to this conversation, so that they would be, because one thing we do in civil engineering is we use some common terminology and don't always mean what it is, like for everyone else. And so, yeah, like stress in civil engineering is a whole lot different thing than stress in your life stress, right? So, so what has been then the path, or what has been the focus of the association once it kind of got up and got going?
Well, probably the thing that really helped us accelerate the rate of use of these materials was a couple things that happened on the federal level. In the year 1993, under President Clinton and EPA Administrator Carol Browner, the EPA made a determination that coal ash, after they studied it, didn't warrant management as a hazardous waste. That was a very important designation. The EPA took a few more years, 7 years to be precise, and in the year 2000, again under President Clinton and EPA Administrator Browner, they made what they called a final determination that coal ash did not warrant management as a hazardous waste, which is very important to investors. Well, the minute that information started to get traction in the investment community, we started to see money flow towards building a bigger beneficial use industry to recycle more of these materials. Because when you're talking about putting these materials into the market, you have a lot of things you need to do. You have to build the logistics, you have to have storage facilities, you have to have trucks and rail capacity, you have to have actually people going out into the marketplace and creating a market, finding customers. Right. There's all kinds of things you have to do that require investment. In 2002, the EPA helped form a industry and government partnership called the Coal Combustion Products Partnership. It was made up of the Environmental Protection Agency, the Federal Highway Administration, Department of Transportation, Department of Agriculture, and in the industry, the utility industry under a group called the Utility Solid Waste Activities Group, and our association. This was a core of this Coal Combustion Products Partnership, or C2P2, as it came to be known. And the objective was to gather information and make it available, do training sessions, and do whatever you could to educate potential user groups and other interested parties on how to use the material. If you look at the utilization rate in the year 2000, when that final determination was made by EPA, the materials were not hazardous, the recycling rate was 29.5%. 8 years later, largely because of the efforts of the C2P2 partnership led by EPA, the recycling rate went up to 44.5%. So that recycling rate in 8 years increased by 50%, And the actual tonnage, if you looked at the tonnage in the year 2000, we were recycling about 30 million tons. In 2008, we recycled 60 million tons. So the recycling rate went up by 50%, the tonnage went up 100%. So that was kind of our golden era of getting the material center stage for a lot of end user groups.
So who are the members of the association then? Is it the utilities? Is that?
Actually, we have a very diverse membership. We're not a large organization. We have about 110 members right now, but our members consist of a wide variety of groups. We have the large coal burning utilities. Most all of them are members of our association. Below them is an industry that was created to market these materials. You have a group of marketers that go out into the marketplace. They secure contracts with the utilities, and they'll manage these materials, sometimes just for sale into the marketplace. Sometimes they provide full service coal ash management to the utility, depending on what the utility wants. So you have utilities, you have coal ash marketers. We have equipment and material suppliers that give us the equipment and materials you need to collect these materials and beneficially use them. We have a lot of engineering consultants. We have contractors who are actually out in the field placing these materials. And we also have some academic interests that participate with us.
So you said it's what's the total number of people?
We have about 110 members.
Okay. So,
and as a result, we have some different interests within our membership because not everybody has the same interest. For example, some of our members are only interested in gypsum, and some of those gypsum people are interested in using it to make wallboard or drywall, as you have in your office.
Sure. Yep.
Or there's a whole group of people that are interested in the gypsum that comes out of power plants for agriculture, believe it or not.
Mm.
So we have, I like to use the term tribes within our membership. Tribes that have special interests don't always intersect.
So how do you become the executive director of this organization?
Good question. I spent most of my career in the ready-mix concrete business, sales, technical service, operations, marketing, those kinds of things. Eventually, I found myself on the staff at the American Concrete Institute, and I was working in some special areas related to chapter development, international relations, some programming things, kind of a variety of things that I was involved with. And in 2008, the executive director of the American Coal Ash Association announced his retirement. And I thought that sounded like a kind of an interesting organization, a little bit I knew about it. And so when I finally came to talk to the retiring executive director, he said, well, they're really looking for somebody to take my place who knows something about the user groups. He said, I'm retiring and I'm a former utility guy, so I know all about generation and management at the utility, but I don't know a great deal about how the material is used. They want somebody who's a user person. So I kind of fit the profile that they were looking for, which is great. It worked out well. And so at the end of 2008, on December 20th, this is important because you'll see in just a second, December 20th of 2008, I accepted the position as executive director. 2 days later, there was a massive coal ash spill at Kingston, Tennessee. An impoundment, a pond had a failure of a containment structure, and it was an extremely large coal ash spill. Fortunately, there was no loss of life or serious injuries. It did tremendous property damage to the surrounding area. But at any rate, we went from a situation where I was hired to go out and take the marketing and promotion and education activities to a brand new level. And all of a sudden, 2 days after I was hired, we were looking at having to fight for survival of the industry. So it was kind of like being made captain of the Titanic just before it hit the iceberg.
That's your first career move is to captain the Titanic. Yeah. So what's the staff? How are you a lone wolf there, and with some administrative staff, or do you have people that are also going out across the country to deliver professional development content and things like that, or is it just you?
I'm responsible for running the association. I have an executive assistant who takes care of the clerical and administrative duties that come along with any organization. Somebody has to open the mail, answer the phone, take care of the website, and all that kind of thing.
Yeah.
My job is to work with our volunteers. We have a lot of volunteers who do a lot of things for us, whether it be educational programs, writing articles for our magazine, creating our electronic newsletter. And we have an event that we work very hard on every other year called the World of Coal Ash, which is the largest event of its kind where the industry comes together. And we have all kinds of different presentations. The last one in 2019, we had over 230 presentations and exhibits, I believe totaled 114. So it's really a big program, and that's one of the bigger things we do, where everybody can kind of gather and kind of take the temperature of where things are. Yeah, that's been very successful for us. We attract about 1,100 people to that. Internationally, we have about 25 foreign countries represented at So those are some of the primary activities that we're involved in with really a skeleton staff, and occasionally we have to go and testify before regulatory agencies seeking information, whether it be on the state level or federal level, and sometimes we're called to visit with other federal agencies and beyond EPA, including Federal Highway Administration, Department of Agriculture, and others in Washington who have information needs, and we also interface with the Department of Energy.
So you and I are both aware there's a lot of organizations within the concrete industry, and I'm sure that's probably true for whatever profession you might be in. How does your association interact with some of these other? So, just as a starter, your office, your address is with the American Concrete Institute. And so when you do go into, so you were saying before we started the podcast that you do some work from home as well as go to the office as a matter of daily business. You didn't have to be quarantined or anything to be in that mode. So, so when you go to the office, you're actually going to the headquarters of the American Concrete Institute.
Yes, we have a contract with the American Concrete Institute to supply back office services for us. ACI has a subsidiary called Advancing Organizational Excellence, which provides services to organizations like ours. So they take care of our accounting, our information technology, help us with our publishing. So they do all those kinds of things. So I don't have to worry about that, and I can concentrate on our mission. So when we're interfacing with the industry, we look at the primary user groups, including the American Concrete Institute and its committees. I sit on some ACI committees that have things to do with fly ash and other applications. We also interface with the National Ready Mix Concrete Association. We're active with ASTM International and the American Concrete Pavement Association. We also interface with some non-concrete industry groups that are very important to us, that are more utility related, so that we keep our eye on what's going on with the power industry, but we don't try to get involved in their issues. Their issues are far too complex for us. We just want to keep an eye on things that affect our ability to get the materials that we're interested in. So in terms of the concrete industry, ACI, National Ready Mix, American Concrete Pavement Association, those kinds of organizations are the ones that we are active with on an ongoing basis.
So it sounds to me like you're making several technical presentations throughout any given year to either user groups or some of these other association members of these other institutes and organizations and such, and that you're probably doing quite a bit of technical writing throughout if you're not on a plane or or in an Uber or a Lyft someplace. Would that be a fair assessment that presentations and technical writing is a big part of what you do in the day-to-day?
Yeah. Yes, it is. I'm fortunate to have people involved in our technical committee who are excellent writers as well. So a lot of times they'll have some expertise that I'm not even aware of that are related to how these materials are handled in a power plant, how they're managed as they're transported from the power plant to storage. A big issue these days is what's called beneficiation of the fly ash, which is just processing the fly ash to make it usable in concrete. And sometimes when we have the ashes come out of the power plant, they're not really usable in concrete, and there's things we can do to those ashes to make them usable in concrete. And that's a big subject of interest now, and we have people that are really good with that.
So what's the challenge or challenges that you're dealing with now that really, it might be a good thing, it might be a bad thing, or, what's sort of front and center on your agenda when you get up in the morning?
Well, here's the good news and the bad news. The good news is the education efforts that we've been pursuing for decades have paid off, and people these days, particularly when it comes to fly ash use in concrete and using this synthetic gypsum in drywall and other products, those industries are doing very, very well. They're doing so well with our products that we can't keep up with the total market demand. As we've seen in the last few years, natural gas has taken over market share from coal in terms of generating electricity. So we see today that about 4 or 5 years ago, coal was responsible for 50% of the fuel for generating electricity in the U.S. Today, that's about 25 to 30%. So we have far less material being generated. So that's an issue because, again, 5 or 6 years ago, there were so many sources, you didn't have to look very far to find a source for fly ash. It was right there.
Right.
Today, those sources are not there. So the ash has to be moved greater distances, and then when you're starting to talk about bigger logistical challenges, you have additional costs, so we're trying to catch up to that. One of the interesting things is as the power plants have either stopped burning coal, or they've retired, or for whatever reason they're not active anymore, some people have assumed that the gap that we're seeing between supply and demand in certain markets means there's no more fly ash, which is not true, because in the survey that we do annual, and we've done an annual survey since 1968 of the production and use of these materials, even in the most recent survey, we showed that there were still 16 million tons of fly ash that was going to disposal every single year. So when folks say, well, there's no more fly ash available, yes, there is. It's just in the wrong place at the wrong time.
So is it going there because there's just nowhere else to put it, or is it substandard material that you don't really want to have in the marketplace?
It's both. It's both. Some of the, as I mentioned, the power plants, when they burn coal, of course, one of their big challenges is controlling emissions. And in order to control emissions and comply with the Clean Air Act, they oftentimes have to inject things into the combustion stream, which end up making the fly ash unusable in concrete. So that's some of that. And the industry's learning to overcome that gradually. The other piece is that oftentimes when you're producing this material and you fill your storage silos and you fill whatever other capacity you have for storing the material and there's nowhere else to put it, it has to go to disposal. So, folks would say, well, why don't you just take that ash and move it to one of the markets that is in need? Well, that requires a lot of transportation assets. Trains, are not always reliable and available. And of course, trucking gets expensive if you're going to go several hundred miles. So while that market 500 miles away might need it, you might not have the transportation assets to get it.
Right. So you mentioned gypsum or I mean, well, you know, basically, you know, sheetrock kind of materials. What other uses? I mean, is there some other organization that's out there that is interested in the same fly ash and bottom ash that represents a different use of it, or do you actually represent the predominant use of the material that is collected, the ash part here?
Yeah, we are the predominant industry group. There are a couple others out there when it comes to wallboard products. The Gypsum Association, that's their name, the Gypsum Association,
Okay.
focuses on those issues, and their membership is primarily the major wallboard manufacturers in the United States. So, but when it comes to the broad range of all beneficial uses, we are the voice.
You're the one. Okay. Okay. Now, the other materials that you were mentioning, so you said that there were 4. What happens with the rest of the, you know?
Of course, fly ash, we know, we find in concrete mixtures, also used as raw feed for Portland cement manufacturing. It's at the front end of the cement kiln. And a lot of fly ash, of course, over the years has found its way into road bases and structural fills and these kinds of things, geotechnical applications.
Yep.
The bottom ash predominantly has been found its way into geotechnical applications. Some of it goes to the front end of cement kilns in certain situations because it has the chemistry that cement manufacturers want to capture. And some of the bottom ash in certain markets is used as a lightweight aggregate in masonry units. So that's another application.
Okay.
The boiler slag is the one that comes out of cyclone boilers. Predominant uses there, one is a blasting grit. A lot of places use silica sand to prepare surfaces for coatings and painting and that kind of thing. This is a good alternate. It doesn't have the silica component that it causes some concerns on occupational health. The other application that you find for boiler slag is if you took a residential shingle, a typical residential shingle, and you took felt the surface, if you feel a real gritty surface to it, that grit is boiler slag.
Okay.
So on about 80% of the residential roofs in the United States, you find shingles that are made with boilers.
Right. Yep. Yep. Okay.
And then the gypsum, the final one, of course, as I mentioned, wallboard, a great sustainability story there. It's used in sometimes in cement production in some plants. As you grind Portland cement clinker to make the finished product, gypsum is added to help control set. Some plants use that gypsum from power plants. And agriculture, 33 states in the United States allow the use of this material in agriculture, and it helps water to penetrate soils, which is really important because as moisture hits the soil, it becomes really fast. It doesn't just run off. It penetrates the soil, and this really helps with a couple things. It helps with more nutrients getting into the soil.
Okay.
You can develop deeper roots for the plants. And the other piece is that as those roots develop deeper penetration into the soil, they can survive drought better. And there are certain plants that really like the nutrients that you find in from this gypsum. Peanuts respond really well to this power plant gypsum. And so we could tell peanuts from which states allow the use and which states don't.
Oh, really? Are they bigger or something, or?
They're bigger and they're a more robust peanut.
Right. Interesting. Interesting. So I'll have to find that out and then go, oh, this must be a peanut from wherever. So.
Absolutely. Absolutely.
So one of the things that is talked a lot about in the civil engineering profession, and you mentioned that in the geotech area, but in the concrete area for sure, the use of this material. But as you said, it comes from the burning of coal and shutting down coal burning power plants is a point of emphasis in parts of the U.S., if maybe not just to say in the U.S. So what is it that I'm assuming that your organization is taking the stance that we shouldn't shut them down, or is it that we should make them more efficient, or what is the position of association relative to this issue, and the consequence of this, and we talked briefly about it before we started the podcast, is when you shut the plants down and you've taken that product out of the pipeline, then users of it now are finding themselves in certain parts of the U.S. as having a depleted supply, or they're having to get material shipped in where they had it locally available before. So long question, but what's happening with this movement to shut down coal burning plants?
That's a great point, John, and we could spend several hours on this. We believe that, number one, if you look at the plants that have retired, that are no longer burning coal, the ones that are remaining in operation have the best control technology that you can get from the industry. So in terms of controlling emissions, these power plants have best technology available. When you look at broadly at energy policy, we try to think of it on the same terms as we do our retirement programs. I know a lot of students that are going to be looking at this haven't think about retirement at all, but when you first hear about a retirement investment plan, the first thing the advisor says to you is, now when you're setting up your 401k plan, don't put any more than 30 to 35% in any one investment. So getting over-invested in any one thing can be bad, and we've all heard the saying, don't put all your eggs in one basket.
Right.
We believe it's in our national interest, not only because it's sensible, it makes sense, but for security of the energy grid, for political security, we can use all of our assets and not rely on other countries, for reliability of supply, a blend of all of our available resources, renewables, nuclear, gas, coal. We have to take advantage of. We have about 250 to 300 years of coal still in the ground in the United States, and we know we can burn it and minimize emissions. In fact, if you look at Japan after the Fukushima disaster a few years ago, they closed all their nuclear stations and they built supercritical gas and coal-fired power plants to replace them, and their emission control is just phenomenal. So I think if you look at it broadly and you think about that, going back to that 401k investment thing, if you put too much in one particular area and then all of a sudden you have an issue. Like today, natural gas prices are extremely low. They're unsustainable. You have people going bankrupt in that business at current prices. Well, if you are relying on that gas supply and your bankrupt supplier is no longer there, you've got an issue.
Yeah, right.
So we advocate a diverse use of all of our assets, again, for stability of the grid, for price stability. If you have a mix of these things, it's not always going to be the cheapest price available, but it's going to be very predictable. And of course, the political consequences of relying on foreign countries to give you a supply is not such a great thing, we've learned over the years.
Yeah. Well, like you said, we could talk for a long time, but we've got to call it a podcast here and wrap things up. But the thing that I think that I'm taking away from this conversation that I hope students do is there's something happening around them that they don't really see it. You don't see fly ash in the concrete. You're not seeing the ponds. You're not seeing this material being moved at a power plant. It's so out of the mainstream of what we do in our daily lives that this is something that's impacting them everywhere they go, because as you mentioned, the various uses. And so I hope they really take something away from this as one of these, boy, I didn't know that at all. And there's a group, there's an organization that represents this. And so they can be involved in from a lot of different perspectives. So I appreciate you enlightening not just them, but me as well. So this is one of those old dog, new tricks. You can always learn something new every day, right? So that's going to be something that's fun for me with all of this. So I really do appreciate your time. I know now too that I'll be following up with you about podcast number 2 somewhere down the road. So thanks so much, and I hope you have a great rest of your day.
Thank you. Appreciate the opportunity to be with you today.
Yep. We'll see you.